So last time we figured out how to do Gaussian elimination by hand. And the problem we worked on is shown here. So essentially we create an augmented matrix, or you can just work with A and B separately. This is just like while writing down, it's easier to carry everything, move everything forward. And the key thing is that A and B are the left and right hand side of the equations. So if we are transforming an equation, we have to transform both A and B. So don't forget B. Okay? You can't just work with A, okay, if you're actually solving the problem. So here I go to, okay, here's my first equation, second equation, third. And what we know about these equations is that I can always multiply equation with a non-zero number and then add it to another multiplication of another equation. And one of those equations I can replace with that linear combination. That's legal, and I'm not changing the solution of the problem. Ultimately, I'm after the solution. So we can do a series of these changes that are legal to help us get to the solution. And one idea in Gaussian elimination is to basically find what to multiply the top row, which I'm referring here as row 1, to be similar to what you do in your differential equations class. And then I'm multiplying with the coefficient and adding to row 2. So basically I'm going to replace row 2 with that linear combination with the objective of getting a 0 here. Okay. And then I'm going to do the same for all of the elements. This is what I refer to as a pivot element, this first diagonal element, which in Python is A of 0, 0, but it's the first diagonal. So in math, it's 1, 1 element. In Python, it moves to 0, 0. So this first so in all of the column, this first or zeroth column, I eliminate these non-zero numbers with using this element. And then I move on to what we call second pivot element, which is in this case now, it has changed in the process, so now it's -2. And I eliminate the number below. Okay? So that process is called forward elimination. Let's try to program it. Okay? So I have uploaded online Lecture6 Gaussian Elimination Template, where I have essentially, there's the template, and I have already typed in this matrix A and B just to move things. So go to the first cell of this template, download and upload. And this is the same matrix. A, it's a 3 by 3 matrix. There is B, which has 3 elements. And yeah, I can print them out. And I'm also going to just test the built-in NumPy solver. We will program a solver ourselves, but we want to see what do we need to get, okay, to see. Though we also solved it by hand, so we have that solution. So if you execute those things, you will get matrix A printed out. You will get my right-hand side B. Recall that there is no column vectors. In NumPy, if they're 1D, they're just a row. And this is my solution, okay? I could have been a little nicer here and say x equals to A equals to and B equals to B. Okay? There we go. So A is this, B is this, X is this. So this is our target, to get this 6. So I need to have a good little example if I'm going to debug a problem. Excellent. So let's now try to actually program this elimination, and I do want to ultimately program it so that it works for matrix of any size, not just 3 by 3. And so I want to automate the process for any size. But let's first do a little bit of warm-up, okay? So what I want you to do here as warm-up exercises in this first cell, print this row 0 of A in Python. We refer to it as R1 when solving by hand. Can you print it out here? And then print the 0th element of B and move on through this 3 or 4 exercises. So is everybody okay with this notation? So this is taking an entire row, 0th row of A, and I can do that with any row, 0, 1, and 2. Right? This is my element of B. Right? And then there's ratio of these elements 1, 0, and 0, 0. That's basically ratio of this divided by this. Why am I looking for it? Technically, when we are solving by hand, we can just eyeball which coefficient would give me a 0. Okay? But I can also simply find that coefficient more generally. I can ask, well, what is a C that I might multiply my A00 with, so that when I add A10, I get a 0. And when I set that, I will get that that's negative A10 over A100, right? So if I multiply this row 1 by that C and add to row 2, I'm going to zero out this element, and I can replace this row with it. Can you do that? That's essentially what I'm asking in that number 4.
So this was my entire row R1 or row 0 in Python. If I need to shift. Oh. No. I'm just going to type it in. This is my row 1 minus C times row 2. I'm going to, for now, print it just to see that I'm doing things correctly. And you can comment this printing of A and B. Okay. So I do see a 0 now. Okay. Did I get this 0 minus 2, 5? Yeah. Now I need to actually replace my entire row with that, so I can just do this. My row becomes what it was before, minus C times first 0 row. Yes? So this is replacing. Is everybody comfortable with this? So, which numbers?
I mean, like the answer for the
Oh, the numbers?
Yeah.
I'm going to print my, it's 0, minus 2, and 5 for that row. But if I print A, you can see that the second row got replaced. When you print A, you will get 0.
I got 3 -1s.
Did you do minus or plus here?
Minus.
And this C was positive?
No.
Okay, so you can either do this and then plus here, or, right? That's okay. Either way you work about. Everybody okay with this? Okay. So now we're going to also do equivalent change in B. So I want to change my B in the same row, right? I changed only A. That's no good. I got to change the entire equation. So what is my corresponding B? Right-hand side. B of, if I want to do the same change,
B of 1.
B of 1 is equal to what it was before minus C times B of 0. Yes? I could have augmented the entire A with B and then just work with the entire row. That's using more memory than I want to use. It's not good for bigger problems. Everybody okay? Now, so this was basically what I did here, is this row. Now I need to do the same for the one below. Let's do that. One more row, right? And I'm gonna do that. I'm just gonna cut, copy, paste. And I'm gonna say, okay, replace row 3, and that's my row 2 in Python, with row 3 minus C, and I gotta recompute C. So now I have a different coefficient. What is my coefficient going to be in more general case here? So it's C times this element now, plus this element has to be 0. So I'm just going to put A2 0 here, right? I'm going to move one element below. Everybody sees that? Again, I'm looking for a coefficient, C, such that C times this plus this gives me a 0. So that's C is minus this over that, right? So I can do the same thing that I did here, okay, with the previous one. I'm just going to change, I'm going to do a copy, and I'm just going to shift this to 2. Wherever I had 1, I'm shifting to 2. 2, 2. Everybody okay with that? So I'm by hand typing in what we were doing kind of by hand in hope of creating an algorithm. Where we're going is trying to see how we can let's print what we get at the end. Okay, I did something right. So is everybody okay finding this C? Okay. And to be precisely the same as these notes, I can make it negative, but then I'm adding things up. So either way, right? Do you want me to be the same as these notes? Doesn't matter. If I make C positive, then I'm going to have minus C here. Otherwise, if I make it negative, you're going to have plus C. So your choice. Okay. Excellent. So this is something that has to work. This is my pivot element. My current pivot element is 0, 0. Okay? It's the first diagonal element. And I have to eliminate all of the values below it in column 0. Yes? So now I want to create a loop that does that, so that even if I have a deeper column and more elements in the column, it's still going to work. So let's first make a loop out of this. I basically repeated the same thing for 2, right? What would the loop be? Can you see sort of a repetition of something? So there was like 1, 1, 1, 1, 1, became 2, 2, 2, 2, 2. That's a good candidate for my I, right? So what I'm going to do is I'm actually just kind of create, because now I'm changing my A as I go in place. So I can just redo what my A and B are, and I'm going to do that loop separately. Oh, actually I did that. So move to the next cell. And let's say I'm going to first say I in, so I had I, or that was column, I like calling columns J. So let's go with J. No, it was going row by row. Sorry, I. I'm going to call it I. And that I was 1 and 2. So that is range of 1, 3. Yes? And I'm gonna copy this, whatever I was doing here, into the cell below and try to do that in the for loop. I'm just gonna replace my 2 with this I. So this is what I'm doing here, is eliminating everything below pivot element A of 0, 0. Is everybody comfortable with this? So just repeated it twice. My range 1, 3 is actually 1, 2. List of 1, 2.
If you put in like range of 1, would that include 0 and 1? Or is it like
Yes, if I put range of 1, that's gonna be 0, 1. No, 0 only. It has to be less than 1. Right?
Oh.
Yeah. But I don't need 0. I'm not doing it for 0. I'm doing it for 0 plus 1, right? Now I'm gonna just generalize this a little. So if you noticed here, I already gave you, so I retyped this A in this cell. I inspected what the shape of matrix is. So technically I have m or n rows, and if m is different from n, then I was complaining here, give me a square matrix, just to throw an error out there. So technically this 3, what is 3? This is a 3 by 3 matrix, so it's either m or n, however you look at it, right? So technically I'm going from 1 till the end of the matrix, so I'm just gonna generalize that and type in an n. So now this technically works for an entire first column, however large my matrix is. Do we see that? The only thing is, like, it works only for that pivot element 0, 0, right? We know in my solving the problem that once I'm done, so I'm done with this elimination. Once I'm done with that, I'm moving over to my next pivot element, which is my next diagonal element, right? So I want to now be able to do it for my pivot element 1, 1. Okay. How is the process going to look like? I'm going to go, my first thing that I'm going to work with is the element below 1, 1. Yes? And then all of the ones, however many below. So kind of, if my element, pivot element is 0, 0, my next one below is 1. If my element, pivot element is 1, 1, my next one below is in row 2, right? And then I don't have any more in 3 by 3 matrix, right? And then I'm done. I don't, if I have this last element 2, 2, I don't have nothing to do because there are no rows below. Okay? So let's try to generalize that a little. What can I do here? So let's now just basically call this I. I'm just going to say I is equal to 0 for now. And replace wherever I see a 0, I'm going to for j. Wherever I see, because I already had an I, okay. Wherever I see a 0, I'm just going to replace it with a j. And the only other thing that I need to replace is this 1. What should it be to be dependent on my j? My pivot element, I go to the first one below.
J plus 1.
J plus 1. Let's see whether this works with this generalization. I still didn't actually execute for any other j. I'm just trying to move to that. This seems to work. Okay. Now I actually want to do that for loop so that I move over to my next j. So instead of j is equal to only 0, I need this to execute for j is 0, 1 in this case, and then I'm done with 2 I have nothing to do with below. Okay. So for j in range in this particular case of the matrix of size 3, I would go to 0, 2, right? If my size of the matrix is actually n, then this is, right? And I just gotta move this over.
Is it n minus 1 because you never go to the third column?
Yeah, actually, even if you go to n, there is nothing in this range, n plus 1 n. That's an empty range, so it's not going to execute. So formally, it's going to actually be okay. It's going to survive. So for my last element, I have nobody below, so I have nobody to work with. But technically, even if you put n here, you're still going to be okay because this range, n plus 1 to n, is not, it's empty. Okay, this should work. Okay, I should actually move over and eliminate what I have. Let's see. I don't know. Maybe I have a typo. We know that typos are nasty. Well, I eliminated this one. Quite frankly, I don't know if we are gonna get the same thing that we did in class, because in class we're kind of picking these coefficients by hand. Where's my next? But let's see. So what I had here is -2 and -1, -9, 2. Is that the same one? It actually is. Okay. So we did the same thing as in class. Yeah, validated. It's always good to have something to check. So this is forward elimination. Technically, step by step. I looked at what I'm doing. I tried to generalize it so I can always apply the same formula. And then I put it in a for loop to work with any matrix. We're yet to test it on a different matrix. We're going to do that in the end. Okay? I have another one typed in. Let's actually now try to, so I'll give you a couple of minutes, to put this loop into a function called forward elimination. And I actually already have sort of the skeleton of that function. It's called forward elimination of AB and returns AB because it's changing AB, so it returns it back as changed. Yes? Can you put this loop into that function without specifying A and B within the function. You don't want to do that within the function because then you're going to overwrite whatever AB comes in. Okay? So you want to just put this generalized part that works with some A and B that are input to the function. So you try it first, then I'll do it. You make your first mistake because you're gonna learn way better. And you have realized by now, because mistakes are common, to this day I will make a mistake, and that's the point of me coding in class, to make a mistake in front of your system. Because yes, you're going to make mistakes. We're human. I'm talking while typing, mistakes will happen. Right? It doesn't matter that I typed this in a number of times in my life. I'm not going to specify the number. Right? I still might make a mistake. And that's just normal. You have to be on lookout for mistakes and actively look for them. And also kind of step-by-step check your results. Okay, so I've done enough talking here. Let me actually then so basically I just grab this main loop. These warnings are already in there. Whoa. And I just have to indent things properly, right? Is this working correctly? I don't know. Let me actually go and retype this A and B. Again, because I've changed it in the previous cell, so I gotta retype it. And then I'm gonna say, actually, just for kicks, A1, B1, forward elimination of A, B. So notice that I actually stored it in a two different matrices. And I'm going to print those just to see that I'm getting the same result as in the upper cell. Huh? So this is the way to test it. Okay, good. So I didn't mess anything up by cut, copy, pasting. Trick question. Have I changed, in this process, have I changed A and B? No. They were passed to the function by the value. What goes into the function stays in the function unless I return it back. I didn't return it back, whatever we got into the function, but I stored it in something under different name. Okay? So in this process here, I did not overwrite my A and B. Because in this very moment, I didn't want to erase those values because then I got to start all over again. Does everybody see that? This is subtle. These two things, A, B, they went to the function. Function is actually doing them and changing them in place and then returning that change, but it's returning that change under different name. If I do want a replacement, then I'm going to type A, comma, B equals to forward elimination A of B. And then it's going to change. Yes? Okay, so my forward elimination hopefully works for any matrix. Great. Now we need to do back substitution. Remember that? So now I actually have an upper triangular system. Okay. Let's go back to how we were actually solving this by hand. So this is my upper triangular system. I start from this last element, right? So my last element is this element of B divided by my last pivot, or this last diagonal element. So that in notation of Python is B2 over A22 because I have rows of 0, 1, and 2. Yes? Once I have that, then I have here diagonal element minus 2, which is A11, times x2 plus 5 times this one that I just computed, x3, is equal to minus 9. So this is gonna be my B1 minus this A12 times x2 that I just computed, divided by A11. Okay? And then I'm gonna move up. Okay? And now I have A00 times x0 plus these two coefficients multiplying x's that I have already previously computed is equal to minus 1. So when I put everything that I know on the right hand side, I get that my x0 is b0 minus this sum divided by a00. So let me actually, again, in the hope of generalizing this to something larger, let me now actually go and type this in as is. X2 equals to something, x1 equals to something, x0 equals, then we're going to start generalizing. Does that help? That's basically what we did for forward elimination. But what I can already see that I have, every time I have x2, I have a b2, x1, b1, x0, b0. So that's going to be my, whatever I want to call those rows during the elimination. And then I have some mysterious sum. This is going to be my problem because this sum is changing actively every time depending on how many elements I already computed, and then divided by A00. Let's type it in first. So I'm going to type into my here I already generalized. Let's just do things by hand first. It's my x of 2. Oh, and I do need to actually I'm gonna now do this forward elimination. So now I do have, I overwritten with my result. So I have upper triangular system, yes? And I'm starting my back substitution. First things first, I need to get myself, where am I gonna store this result x? And it's the same size as b, right? So I'm going to create an empty array. I already have what n is, so I don't need it. So my x of 2 is b of 2, whoops, divided by a of 2, 2. Yes? It's right there. Then my x of 1 is b of 1 divided by a minus a of typing 2 times x of 2 that I just computed just before that. And all of that divided by I have tried really hard not to make a typo. No guarantees though. What I'm gonna do though, I'm gonna retype, since we're gonna probably execute this more than once, I'm gonna retype this A and B here. Just in case I go through this multiple times. Everybody agrees with me? I'm just kind of typing in what I was doing by hand, and technically for any 3x3 system, this would do it. If you're ahead of me, try to generalize this. And then what I'm doing, I'm printing my x to see whether it's the same as what we got at the beginning. There's another way to check whether something is a solution. You can multiply a times x and then deduct b, and you should get 0, 0, 0. It appears that I did it correctly. Are we still following questions? Did I lose you completely? You checked out like 15 minutes ago? But didn't tell me? I typed it in, right? It's now doing it correctly. Now we want some sort of a loop. I don't want to type this for 100 of them. Okay. And the similar strategy as we had before, okay, is that it seems to be, so you recognize what's the same here. There is some mysterious sum that doesn't exist in my lab, like when I don't have anything computed, it doesn't exist. Then after that, there's the sum that takes into account all of the previously computed x's and multiplies coefficients that exist in A with those x's and sums them up, right? Now I will stop here. So I will basically say, okay, all of my x's they start from the last one. This will give me the range of x's, correct? If I put the 0 here, then 0 will not be included. And I do have to decrease by 1, right? I hate that part about that range function, but here it is. It's a source of a lot of error. And then my x of I, nobody's listening anymore. Minus this sum s that's going to be divided by a of I. All right. Everybody's like, we're leaving.
It's Friday.
Huh?
It's Friday.
I know.